So yeah.
Awesome. So next up, we have the Riemann Hypothesis.
Ooh, that classic.
And so, once again, I'm not going to repeat it. This is a hard question, okay? or a hard problem here. And the Riemann hypothesis is related to the Riemann zeta function, which is a complex function, right? And basically, the roots of the Riemann zeta function have like negative integer. It has negative integer roots and also imaginary complex roots with a real part that is 1/2. And so, as we explained in our types of numbers episode, when you have a complex number, you have a real part and an imaginary part. And so, as what I just said here, the roots, when the zeta function is equal to 0, we can have solutions that have a complex part, and every single complex solution has a real part that is 1/2. And this is related to the separation of prime numbers, which we should actually talk about prime numbers. Make an episode about prime numbers.
I was just thinking about it because that's
awesome
a really
topic.
Interesting. Prime numbers themselves, I think, Parker and I were talking about this before we started. Prime numbers are so interesting because they're all throughout the number line, and they're all spread out, without a specific pattern. And I guess like the entire, or one of the major ideas of the Riemann hypothesis is to find a pattern to the prime numbers. Mm-hmm. And is there a pattern to the prime numbers? That would be amazing. Wow.
Yeah, that would be absolutely amazing, because as some people would know, I guess, like prime numbers are very rare, right? The higher you go on the number line, the easier it is to find like what's it called, factors, right?
Yeah.
The easier it is to find factors of numbers, and so the higher you go, the more spaced out these numbers are. But up to date, turns out there's actually no pattern to find prime numbers.
That's amazing.
And so to actually find prime numbers, there are like supercomputers out there working extremely hard. They just go I don't actually know how they do it, but I'm guessing they just go number by number.
Just check
they go number
divisible.
by number, and they just check all the factors, and then until they get to a number, and they say, oh, it doesn't have any other factors except for 1 and itself. Boom.
I'm pretty sure that is actually how they do it, because I think I know what you're talking about, like these supercomputers that the primary focus is to find prime numbers, and recently, I think this was a number file video where they found some ginormous prime number, like something to the exponent of something huge. And again, that was obviously found by a supercomputer, and that's the largest prime number that we know till date. And again, the interesting thing is that we have these numbers that go into the millions and billions, if not a lot more than that, and we still haven't been able to find a pattern. I think that's crazy, because I don't know, there are a lot of parts of reality, there are a lot of parts of, physics and science that simply make sense. Like, F equals ma, like that makes sense. That works for every single object. I mean, except for the extreme cases. It basically works for everything. It makes sense. And
it's funny that we have to mention that.
Yeah.
like, our theory works every single time, except for when it doesn't. But
there are special cases for sure. There are special cases. But again, the point I was trying to make is that it's so interesting that there are these numbers that exist in reality, that we can count, we can measure, that don't make sense. They just don't make sense. There's no pattern, there's no relationship between them, and everything is kind of just lost. So I think that's a little interesting and weird, but interesting, Definitely. More interesting for sure.